Hey everyone, welcome back to the channel. Today, we're exploring the power of Python functions, covering loops, function arguments, key arguments, and default values, arbitrary argument list, returning multiple outputs, docstrings, and end with a fun application of the ideal gas law in Python. Let's get started. First, we discuss the concept function with branches loops. If else statements are control mechanisms that execute specific code blocks depending on given conditions. Loops, on the other hand, facilitate the repeated execution of a code segment as long as a specified condition remains true. Both if else constructs and loops empower effective decision making and repetitive operations in programming. This program calculates the fees charged by eBay for selling items using a well structured Python function that incorporates conditional branches if else. The function calc eBay begins by defining key variables, a flat listing fee of 0.50 and percentage rates applicable to different price ranges. For items priced at $50 or less, the fee includes the listing fee plus 13% of the selling price. For items priced between $50 and $1,000, the fee adds 5% of the amount beyond $50 to the previous tier's calculation. For items priced above $1,000, the calculation incorporates 2% of the amount exceeding $1,000 in addition to the fees from the lower price ranges. These calculations are performed using a combination of logical branching and arithmetic operations, making the program both dynamic and modular. The user inputs a selling price, and the program outputs the corresponding eBay fee in a formatted manner. This example highlights how functions, combined with conditional logic, can simplify real world scenarios like fee calculation, making the code reusable and easy to understand. Alright, let's put your understanding to the test. How well did you grasp the concept of functions with branches and loops? Here's a challenge for you. When this function is called, how many assignment statements do you think will run during its execution? Take a moment to analyze the code and share your thoughts in the comments below. Here's your next challenge. What will this function return if the sell Joe price argument is zero point 0.0? Take a moment to review your answers and match them with the concepts we've covered. Let me know in the comments how many you nailed and how confident you feel about mastering this topic. Next, we explore the concept of function arguments. In Python, arguments are passed to functions using a pass by assignment mechanism, where they are passed by object reference. Local variables are created within the function's local scope during the function call, and parameter names are assigned to the arguments provided. If the function modifies a mutable object, like a list, those changes will directly impact the original object outside the function. This example demonstrates the concept that assignments to function parameters do not affect variables outside the function. The function birthday age simulates a birthday celebration by incrementing the age parameter by 1. Initially, the variable Timmy age is set to 7, and both Timmy age and age reference the same object when the function is called. However, within the function, the assignment age is equal to age. Plus 1 creates a new local object for age, leaving Timmy age unchanged in the global namespace. As a result, when the function finishes executing, the global variable Timmy age still holds its original value of 7. Therefore, the final print statement displays Timmy is 7, illustrating that parameter assignments in a function only affect the local namespace and do not modify the original variable outside the function. Next, this example illustrates how modifying the elements of a list inside a function affects the original list outside the function. The function modify numList takes a list as an argument and changes the value of the element at index 1 to 99. When the list myList is passed to the function, both the local parameter numList and the global variable myList refer to the same list object in memory. Consequently, any modification made to numList within the function directly updates the original list myList. As a result, after the function call, myList reflects the change and contains the updated value 10, 99, 30. This behavior demonstrates that lists, being mutable objects, retain changes made to their elements when passed as arguments to functions. The program illustrates how to prevent unintended changes to a mutable object by passing a copy of the list to the function. This ensures the function modifies the duplicate while leaving the original list intact. In this example, the modify function is designed to alter the second element of the provided list, setting it to 99. However, when the function is called using myIList, a slice of the list is passed to the function. Inside the function, the modification only affects this duplicate copy of the list. Since the original myIList remains untouched, the subsequent print myIList statement outputs the unchanged original list 10, 20, 30. This approach is useful for maintaining the integrity of the original data while allowing the function to manipulate a temporary duplicate for specific purposes. Now that we've explored the concept of function arguments, it's time to test your understanding. I've prepared a few quick questions for you. Reflect on each one and share your answers in the comments so I can check them out. Here comes the first question. Can changes made to a parameter inside a function ripple out and affect the world beyond the function? Think it through and choose wisely. Here comes the second question. When a function is called, do you think it works with exact copies of the argument objects, or does it handle something else entirely? Analyze your answers carefully and compare them to the concepts you've studied. Let us know in the comments how many you answered correctly and how confident you are in your understanding. Next, let's dive into the concept of keyword arguments and default values. Keyword arguments make your code more readable by explicitly showing the purpose of each parameter. They help avoid errors caused by misordering parameters. Often, keyword arguments come with default values, allowing certain parameters to be optional. Additionally, you can specify keyword arguments in any sequence, offering greater flexibility in function calls. The first program demonstrates a function with multiple arguments, requiring precise ordering of values during the function call. The print book description function accepts details about a book, such as its title, author, publisher, year of publication, version, number of chapters, and total pages. When calling the function, all these arguments must be provided in the exact sequence as defined in the function's signature. For instance, the function called print book description specifies all the details in order, which ensures the correct mapping of values to their respective parameters. In contrast, the second program demonstrates the use of keyword arguments, offering flexibility in specifying the parameters. Here, the print book description function accepts the same arguments, but the values are explicitly labeled with their parameter names in the function call. This approach eliminates the need to follow a strict order, as seen in the function call print book description. Keyword arguments improve code readability and reduce the chances of errors caused by misordered parameters, making them especially useful when dealing with functions that have numerous arguments. Default parameter values are preset within a function and are automatically used when no corresponding argument is provided during the function call. These defaults make certain parameters optional, streamlining function calls for typical scenarios and reducing the need to specify values repeatedly. This program demonstrates default parameter values using the print date function, which formats a date based on the style parameter. With a default value of 0, the style parameter defaults to the American format, month, day, year, if not explicitly provided during the function call. Inside the function, a conditional statement checks the value of style. If style is 0, the date is printed in the American format. If style is 1, the date is displayed in the European format. Any other value for style results in an invalid style message. The program includes three function calls. The first specifies style 0, resulting in the output 7:30, 2012. The second call sets style 1, producing the output 37, 2012. The third call omits the style argument, relying on the default value of 0, which again outputs 7:30, 2012. This example highlights how default parameter values simplify function calls by making specific arguments optional. This example illustrates how mutable default objects like lists persist changes across multiple function calls, and how to address this behavior. On the left side, the function append to list has a default parameter, my list initialized to an empty list. When called without specifying my list, the function modifies the same default list in memory, resulting in cumulative changes. For example, calling append to list appends 50 to the default list, producing 50, while the subsequent call append to list 100 appends 100, resulting in 50 100. The right side of the program resolves this issue by using none as the default value for my list. Inside the function, a new empty list is created locally if my list is none. This ensures that each function call operates on a fresh list. Consequently, calling append to list 50 creates a new list, 50, and calling append to list 100 later creates another new list, 100. This approach avoids unintended modifications to a shared mutable object and ensures the function behaves as expected for each call. Now that we've explored keyword arguments and default values, let's put your knowledge to the test with a few practice questions. Take your time to think through each one, and don't forget to share your answers in the comments below. Here's the first question for you. When using the split check function to split a bill, if you call it a split check, what value will be assigned to the tax percentage parameter? Could there be an error in this call? Here's your second question. If you call the split check function like this, split check, what value will the tax percentage parameter be assigned? Take a moment to review your answers and reflect on how well they align with the concepts you've learned. Let's explore the concept of arbitrary argument lists. These allow functions to handle an unpredictable number of arguments. By using asterisk args, you can gather extra positional arguments into a tuple. This is particularly useful when the number of inputs varies, making your function more flexible and adaptable for different use cases. This program demonstrates the use of arbitrary positional arguments with the asterisk args syntax in Python. The print sandwich function takes two required arguments, bread and meat, and any additional ingredients in asterisk args. The function prints a description of a sandwich, starting with the specified type of bread and meat. If extra ingredients are provided in asterisk args, it appends them to the description, separated by spaces. In the first function call, print sandwich, sourdough, turkey, mayo, only one additional argument, mayo, is passed, producing the output, turkey on sourdough with mayo. In the second call, print sandwich, wheat, ham, mustard, tomato, lettuce. Multiple additional arguments are passed, resulting in ham on wheat with mustard, tomato, lettuce. This example highlights how asterisk arg senables functions to flexibly handle varying numbers of positional arguments, making them versatile for different use cases. Double asterisk kwargs gathers additional keyword arguments into a dictionary where the keys represent the parameter names provided in the function call. This program demonstrates the use of double asterisk kwargs in Python to handle an arbitrary number of keyword arguments. The print sandwich function requires two positional arguments, meat and bread, and collects any additional keyword arguments into a dictionary using double asterisk kwargs. The function prints the basic sandwich description with the specified meat and bread. It then iterates through the double asterisk kwargs dictionary, printing each key value pair to describe additional customizations, such as sauces or vegetables. For example, the first function call outputs turkey on sourdough with sauce mayo, while the second call lists ham on wheat with various customizations like sauce 1 mustard, veggie 1 tomato, and veggie 2 lettuce. This flexibility allows the function to accommodate varying numbers of keyword arguments. This program demonstrates the use of both asterisk args and double asterisk kwargs to handle arbitrary numbers of arguments in a function. The function gen command constructs a command string for a given application. It accepts a required positional argument, application, which specifies the name of the application, and a variable number of keyword arguments via double asterisk kwargs. The function initializes the command string with the application name and iterates through the key value pairs in double asterisk KW args. Each pair is appended to the command string in the format key value. Finally, the completed command string is returned. After exploring the concepts of arbitrary argument lists, it's time to test your understanding with a few practice questions. Reflect on each question carefully and share your answers in the comment section below. Here's a challenge for you. Can you complete the first line of this function definition? Remember, it needs two required arguments and the flexibility to handle any number of extra arguments. Think you've got it? Here's another challenge for you. Your task is to complete the function call so that the output of the program is the function printstats takes a name and an arbitrary number of keyword arguments using double asterisk info. It then prints the name followed by the key value pairs from the info dictionary. Can you figure out how to pass the arguments to make the program output the correct details about John? Let's see if you can crack this. Take a moment to reflect on your answer and how well it aligns with the concepts you've studied. Feel free to share your thoughts in the comments and let us know how confident you feel in your understanding of the material. Next, we discuss the concept of returning multiple outputs. In Python, functions are designed to return only a single value. However, sometimes you may need to return multiple values. A common solution is to group these values into a single container, such as a tuples, and return it. This program calculates the average, mean, and standard deviation of a set of student test scores. The getGradeStats function first calculates the mean by summing all the scores and dividing by the number of scores. It then calculates the standard deviation by computing the square root of the average of the squared differences from the mean. These two values are returned as a tuple, allowing multiple outputs to be returned in one statement. When the function is called, the tuple is unpacked into two variables, average and standard deviation, and the results are printed. The use of a tuple to return multiple values is efficient and allows for easy unpacking, making the code more readable and concise. The program's output shows the average score and the standard deviation, providing a clear summary of the score's central tendency and variability. Now that you have a good understanding of returning multiple outputs from functions, it's time to challenge yourself with some practice questions. Take your time to carefully work through each one and feel free to share your answers in the comments below. Here comes your first question. Take a look at this statement. Is it a valid way to return multiple outputs from a function? Think you know the answer? Give your answer in the comment section for me to review. Here's comes your second question. Can a function return multiple objects at once? Take a moment to think and make your choice. Let's see who can crack this one right. Reflect on your answers and check how well they align with the concepts you've learned. Feel free to share in the comments how many you got correct and how confident you are in your grasp of the topic. Let's dive into the concept of docstrings. Docstrings provide a concise explanation of a function's purpose and are written at the beginning of the function body. They are enclosed in triple quotes, with no blank lines before or after the docstring. For straightforward functions, single line docstrings are used, while more detailed functions require multi line docstrings. Multi line docstrings should describe the function's arguments, maintain consistent indentation, and include a blank line before the closing triple quotes. In this example, two functions are defined, each with a docstring to describe their purpose. The first function, numbed seats, uses a single line docstring to briefly state its purpose, determining the number of seats on a plane. The docstring is enclosed within triple quotes with no blank lines before or after. The second function, ticket price, includes a multi-line docstring to provide a more detailed explanation. This docstring not only explains the function's purpose, calculating the price of a ticket between two airports, but also describes the arguments the function takes, including the optional keyword arguments for coach and first class ticket pricing. The multi-line docstring uses consistent indentation and includes a blank line before the closing triple quotes, making it clear and readable. Finally, let's explore the concept of the ideal gas law. The ideal gas law is an equation that describes the relationship between the pressure, volume, and temperature of a gas. This program uses the ideal gas law to compute the temperature of a gas given its pressure, volume, and the number of moles. The function convert to temp takes in three parameters: pressure, volume, and the number of moles of gas. It then applies the rearranged ideal gas law equation to calculate the temperature, where R is the gas constant 8.314621. The program prompts the user to input the values for pressure, volume, and moles, and outputs the calculated temperature in Kelvin with two decimal places. For example, when the user inputs a pressure of 2500 pascals, a volume of 35.5 cubic meters, and 18 moles, the program calculates the temperature as 593.01 Kelvin. This demonstrates how the ideal gas law can be applied in practical scenarios to calculate unknown properties of a gas. Now that you've mastered the ideal gas law, it's time to put your knowledge to the test. Take a moment to consider the question carefully and share your answer in the comment section for feedback. Here's your first challenge. Think carefully about the function and the formula it uses. Does it align with the rearranged version of the ideal gas law? Drop your answer below and let's see how you do. Here's your second challenge. Take a closer look at the function and consider how the gas constant is being handled. Is it a global variable or passed as an argument? Share your answer below. Review your response and assess how it aligns with the concepts you've studied. Feel free to share your thoughts and how confident you are about your grasp of the material in the comments. In conclusion, we've explored some essential concepts of Python, including functions, variable arguments, multiple outputs, docstrings, and the ideal gas law. These topics are foundational to writing clean, efficient, and flexible Python code that can handle diverse situations, from accepting arbitrary numbers of arguments to documenting your code properly with docstrings. By understanding how to use *args and double *kwargs, as well as returning multiple values in a single container, you can make your code more dynamic and reusable. The ideal gas law example tied these concepts together, demonstrating how we can use Python to solve real world problems. Keep practicing, stay curious, and continue experimenting to sharpen your skills. If you enjoyed this tutorial, please like, comment, and subscribe to our channel. See you in the next video.